Okay, this is John Marsh, and I'm here to do example problems from homework number 1 in NCS 210 in the fall of 2013. And the first problem on homework 1 is problem 3.1 in the text, asking you to convert frequencies into periods, basically giving you the frequency and asking you for the period. And you'll see that we have hertz, megahertz, kilohertz, so we have to do some conversions here. So I'll start with Forouzan Chapter 3, 3.1 here, and given F, calculate T is what we're supposed to do here. And for part A, F is given as 24 Hertz. So I'm hoping to illustrate for you the problem-solving procedure. So you write down what you're given. You write down also what you know. You know that the equation for the period is given as 1 over F. So you write down everything you know, and now we have everything we need to calculate T. All we have to do is invert F. And we're going to plug in the number 24 because Hertz, we're already in Hertz. And I get 1/24 or 0.042. And this has units of seconds, but I'm going to move the decimal point over 3 places and write 42 milliseconds. Okay? And this I typed in on my calculator. For part B, and again, we plugged in 24 directly because we were already in Hertz. We didn't have to convert a milli or a kilohertz or a megahertz value into Hertz. You want to bring everything back into base units without any metric prefixes when you plug into most of these equations. So if we do part B, F is 8 megahertz. And I'm going to immediately convert that into the base units of Hertz, which is 8 times e to the 6th Hertz, or 8 times 10 to the 6th, or 8 million Hertz, or 8 with 6 zeros. And again, same process, T equals 1 over F. And here I'm going to plug in units of Hertz, 1 over 8 E6, and I'm going to get 0.125, which is 1/8, times 10 to the negative 6th. And I just took the 10 to the 6th in the denominator and brought it up as a 10 to the minus 6 in the numerator. And then I'm going to rewrite this as, and this has units of seconds, and then I'm going to multiply by 1,000 and divide by 1,000. When I multiply by 1,000 on the front part here, I have to divide by 1,000 on the exponent. And so this is still in seconds, but now I have 125 nanoseconds. Okay, so a 10 to the minus 9th is a nano. Okay? You need to do enough problems that you're perfectly comfortable getting from the 0.125 e minus 6 to 125 nanoseconds. You could just as well write 0.125 microseconds. 10 to the minus 6 is a micro. Okay. For part C, F is 140 kilohertz. And I am going to immediately put that in as 140 times 10 to the 3rd hertz. And I'm going to plug into the same exact equation, 1 over 140 E3. And when I plug that into my calculator, I get 7.14 times 10 to the minus 6 seconds, or 7.14 microseconds. Okay, so there's problem 3.1. And I'll stop the video here.